Hi scholars, happy Thursday. Today we're going to be finishing up chapter 2 of unit 9. We're going to be doing 12 to the end of the chapter. Yesterday you should have read pages 8 through 12. Today we're going to wrap that up and we're going to talk about water cycle and telling the difference between some of our bonds that we've discussed so far. First up, we have our do now warm-up of the day. We're going to review some vocabulary we've talked about on Monday, Tuesday, and Wednesday so far. Some of this should be really familiar, especially yesterday's. Our vocab words are matter, mass, property, physical as an adjective, embedded as an adjective, the verb evaporate, our new adverb from yesterday, reluctantly, and lastly our adjective portable. You're going to be matching them up with definitions. What is visible to the eye and measurable? So if you can see it and touch it and measure it, what is it? Fix deeply into the surrounding mass. So if something's really stuck in there and you can't get it out. The amount of matter in a substance or object. If we're trying to weigh it, we're trying to figure out it's what. It's the amount of matter in it, or it's D, any substance that occupies space and has mass. So if it has mass and it takes up space in my hand, like my phone, it's made of what? Unwilling. If you are unwilling to do something, you are doing it what? Remember, it's a way that we're describing a verb. If you are unwillingly taking a bath or taking a shower, it's an adjective to describe a verb, so it's an adverb. F, if it's easy to carry. If it's a phone, you probably want it to be easy to carry. You don't want to have to lug it around like an old backpack. G, a feature about a piece of matter. So if it's a part of it, every piece of matter in the world, like my phone, has features on it. So I could talk about a camera. I could talk about how it feels. And lastly, F, to turn from a vapor into a liquid, or turn from a liquid into a vapor. Matching our terms, matter is D, any substance that occupies space and has mass. If it has mass, it has matter. Mass is C, the amount of matter in a substance or object, how we weigh it or know how big it is. A property is G, it's a feature about a piece of matter. So what are the properties of this cell phone? What are the properties of this object? Physical is A, what is visible to the eye and measurable. So it's a physical trait. It's an adjective. What physical things do we notice about this? How does it feel? How does it taste? How does it look? How does it sound? Embedded is B. It's fixed deeply into the surrounding mass. So if it's really stuck in there, it's embedded. Evaporate is H. To turn from a liquid into a vapor. Reluctantly is E. You are unwilling to do something. Unwilling to do something. And then portable is F. It's just easy to carry. It means it's easy to get it around. You would prefer a phone to be portable. Our daily objective for the day, I can integrate multiple sources to explain the concept of chemical states. So we're going to talk about different chemical states today, and we're going to talk about different sources that they use to explain it to us, such as fossils or the rain cycle. Scholars, we're going to take this time to finish chapter 2. We're going to be reading from the top of page 12 to page 15 to wrap it up before moving on to discuss the different states of matter that they elaborate on in this chapter. Starting at the top of page 12. So if ice, water, and water vapor are all the same kind of matter, what explains the different states? Matt asked. Excellent question, Matt, Tess replied. All matter is made of small particles, so small that they can't be seen with the naked eye. Whether a type of matter is in a solid, liquid, or gaseous state depends on how tightly packed these molecules are and how much energy they have. In a solid, such as an ice cube, these particles are crammed together. They can wiggle, but they don't have enough energy to do much more than that. A solid keeps its shape because its particles are in a fixed position. Tess took a sip of the bottle of water. Matter in liquid state, like the water in this bottle, has particles that are further away than those in a solid. They have more energy too, and enough so they can move and slip freely and slide past each other. That's why liquids flow. Matter in a liquid state doesn't have a fixed shape. It takes the shape of whatever space it occupies. She held up her bottle and it tipped from side to side. So scholars, if you've ever made ice cubes at home or in an ice tray, it's already divoted out. There's those little like square holes that you fill up with the water. That's because matter takes the shape of whatever form space it's in. So we pour in a liquid and the liquid would become whatever it's molded into. So it's the same thing if you're making a popsicle, you'll pour the juice into the container, put a stick in, and that's why later it comes out in a specific shape. Matter in a gaseous state, Tess continued, is made up of particles that are farther apart than those in a liquid, and much further apart than those particles that are solid. And they have more energy too. There is so much space between gas particles that they can move freely and rapidly in different directions. A gas spreads out to fill whatever space is available. Tess spread her arms wide, and here in Montana, we have lots of space. So if you've ever been boiling water to make pasta or macaroni before, you know the water is ready for the noodles when it starts bubbling up and you see all the steam and water vapor rising up. If you've ever burnt food or noticed someone burning food before, you've probably smelled it before you even noticed it because the gas moves so quickly. You have to maybe open a door for it to get out of your place, crack a window for all that gas to get out because gas moves quicker than any of these other forms of matter. Julian scooped up a handful of cold water in the bottom of the cooler and splashed it on his face. So my question is, how do we get more ice? I'm not too keen on drinking warm water. Fortunately, physical changes in matter are reversible, Dr. Forrester chimed in. Matter changes states when heat is added or taken away. For example, ice melts if it gets warm. Chill that water by removing heat and it turns down to ice. That's why our portable, battery-powered refrigerator back at camp can do it. It keeps our food cold and even makes ice. She glanced at her watch. How about we work for another half hour or so, and then we head back to camp for dinner? Dinner! Yes! Felix cried, pumping his fists into the air. But you just ate 3 energy bars, Daria said, looking amazed. That was nothing, Felix replied, because in half an hour I'm certainly going to be starving again. My mom says I burn calories really fast because I never sit still. He leaped up and started doing a little dance along the edge of the plateau. It seemed to Amy that what happened next unfolded in slow motion. Just as Dr. Forrester called out for Felix to be careful, part of the rock ledge where he was dancing gave way. Felix swayed, trying to keep his balance. His eyes grew wide, and the next instant, he was gone. Everyone scrambled to the edge and looked down. Felix was sitting at the bottom of the gully, about 10 feet below, with a surprised expression on his face. Dr. Forrester's face was dark with worry. Felix, are you all right? Felix jumped to his feet and started dusting himself off. I'm fine. I really didn't fall. I just scooted down on my backside. He started to climb the slope, but paused to pick up something from the gravelly bottom of the gully. What do you make of this, Dr. Forrester? He asked when he was back on the plateau. He held up what looked like to Amy, looked like a dark oblong rock. Oblong, scholars, is just an adjective to describe a circle. Think of like an oval. Dr. Forrester gripped him by the shoulders. Never do anything like that again, she said sternly. You could have been hurt. Then she looked carefully at Felix's find. It's definitely a piece of fossil bone, she said, turning it over and over in her hand. She nodded towards the gully. I think I'll hike down there and have a quick look around. 15 minutes later, she was back with several more fossil fragments. Everyone gathered around as she laid them on the ground. What kind of animals are they from? Crystal asked, pulling out her sketchbook and beginning to make drawings of the bones. Dr. Forrester shook her head. I won't really know until I've looked at them more closely. Let's pack up our gear and head back. Back at camp, Amy and Julian helped Tess make spaghetti in the tent that served as a kitchen. When dinner was ready, everyone gathered around a table, sat outside. Tess went to the lab to get Dr. Forrester, but she came back alone. Dr. Forrester says she'll eat later, after she's done studying those little bones. The sun set while they were eating, and a cool breeze sprang up. When they had finished making dinner, Crystal and Matt did the dishes. and Tess brought a huge bonfire with thick chunks of wood. Everyone gathered around the fire, and Amy was surprised at how good the heat from the flames felt as the temperature kept dropping. Suddenly, the fire popped, and sparks shot up in the air. Whoa, Daria said, scooting back a few feet. I think a log just exploded. It did, because water changed states, Tess said quietly. What, chemistry again? Felix teased. Tess just smiled. Logs often have small pockets of water and sap in them. As the logs start to burn, the water gets hot enough to boil and change states to become a gas. But the gas is stuck inside a log. Pressure builds as the gas gets hotter until at some point the wood gives way with a pop and the hot gas escapes. So scholars, if you've ever been watching a campfire before, or if you've ever been at a bonfire, that's what those little like pops or like explosions sounds like coming out of the fire. It's all the water and sap trapped inside the logs, and when they turn the gas, they kind of explode to get out. Just then they heard footsteps, and Dr. Forrester appeared in the firelight. Those little fossil bones are very interesting, she said. I'm thinking they might belong to a small dinosaur, rather than an ancient mammal or bird, but unfortunately, I don't have enough pieces to be sure. I want to look at them, Julian said, jumping up from his chair and headed for the lab. Dr. Forrester caught him by the shoulders. If you don't mind, Julian, let's wait till morning. It's really time for everyone to head to bed. Julian shrugged and reluctantly said, Okay. As Amy walked with Crystal and Daria to their tent, she suddenly remembered the snakes. Were snakes coming out of their daylight hiding places now that it was cooler? With one eye peeled for anything slithery, Amy brushed her teeth with water in a cup and spit the minty foam onto a rock beside the tent. Then she checked to make sure that nothing was in her sleeping bag before crawling inside. Daria and Crystal were quickly asleep, but Amy lay stiffly on her cot, listening for rustling sounds. Finally, she got up and shone her flashlight into every corner of the tent, under all the cots, and then zipped up the tent flap. She was pretty sure there was no other way for snakes to get in. Even then, though, sleep refused to come. Amy flicked on her flashlight and pulled out one of the books she had brought along, The Mystery of the Old Masters. She had read the book many times, but she was never tired of reading how Inspector Ellis figured who'd stolen the priceless paintings. She thought it was really clever the way the inspector kept track of clues on a small notepad and consulted this list often. After finishing the first chapter, Amy felt better. She had just wished that instead of fossil camp, she could have gone to detective camp, if there was such a thing. Now that we've finished chapter 2, we're going to look at the next page in our packets, and we're going to start analyzing, and we're going to make a chart of the different states of matter that water goes through in its cycle. So, as we can see on our activity page, on the next page, we're going to be looking at the different states of matter in our water cycle, and we're going to use these 3 little icons in each box to show at what state the water is in. These are an illustration and a representation of the molecules inside the water. So remember, if it's a solid, they're packed very closely together and it's the slowest moving form of it. They don't have a ton of energy. If it's a liquid like water, it's flowing around, it's a little bit more loosey-goosey, it can move pretty quick. If it's a gas, gas goes everywhere all at once. If you look at the image, it looks like every molecule shooting off in a different direction. It's really hard to catch gas in your hand. Think of it like that. You can hold something solid in your hand. It's difficult to keep a liquid like water in your hand. It's kind of like going everywhere. And a gas, you can't even catch it in your hand. It just disappears. It slips through the cracks because the molecules are heading everywhere. So you should have this exact same chart or graphic in your packet. I'd like you to fill out and follow along and complete each step of the water cycle. We're going to start with the top right corner with precipitation, which just means rainfall. You've probably talked about the water cycle in science class so far, so this might just be a quick, brief refresher. So in precipitation, it's a liquid, so we're going to illustrate the molecules like liquids. They're spaced apart, they're flowing along, it's falling down. It lands on top of a mountain where it becomes snow. When it's snow, remember, it's more of a mass. They're packed together, so the molecules are very close in our second box. In our third box on the right-hand side, it's still melting, but it's still in a solid state. But the very bottom, when it's melted all the way and becomes rainwater, or in that lake, it becomes a liquid again. If you move over to the other side on the bottom left box, and continuing our cycle, we know it's still a liquid, but it's starting to warm up. After that, if you go up, It's evaporating as a gas. This is water vapor. So it's a gas that's going everywhere. And then that second box on the left-hand side, now we're in a cloud. We're in condensation. So it's starting to be gaseous and it's going everywhere. And then when it's back at the top, it's going to rain again, and then it's in a liquid state, just like how we began. So if you look at it, it looks like we have a cycle. We always have two in the same thing in a row. We always are going to have it in a liquid state, then it goes to a matter state, gaseous state, and then so on, so on. The last thing you have to do today that I'd like you to submit a photo to me of is a race response. So there are many examples in our reading about things changing state today. They specifically talk about water bottles today. We focus on the water cycle and how each molecule movement is different in each state. Using water as your example, I want you to explain how it changes from a liquid to a gas or a vapor, or from a liquid to a solid. So I already have your race response starter. Water changes its state from what to what because ... I just gave you a lot of examples and evidence for your race response in our last slide. So if you need to skip the video back a minute or two, let's keep your ears open and you'll find some good methods about how water changes from a liquid to a gas or from liquid to a solid. You're describing how it changes from one state to another. After that, make sure you text or email a picture to me. In the meantime, scholars, I will see you tomorrow, Friday, for our next video. Stay safe and have a great day.